All right, here we go, guys. So I guess basically, I think these are relatively easy. But I do want, if anybody's having trouble, does anybody need me to go over 11, 12, or 13? Anybody need me to go over 11, 12, or 13? But it's really easy. Angles 9 and 10 are supplementary because they form a linear pair. So you just set them equal to 180. On number 12, 3 and 4 are vertical angles, right? So they are equal to each other. All right, does anybody have any questions with 11, 12, or 13? And again, remember, the key is to make sure you're checking. 11, 12, or 13. Yes, sir. Yeah, we're going to take a look at the proofs here in a minute. You got a question? No, I don't. No. Yeah. No. I don't care about naming the theorems here. All right. You guys know that. I care about the proofs are when you're going to name the theorems. All right. The proofs are where you're going to name the theorem. So now, Reed, you want me to take a look at number 15? Yeah. All right. Now, number 15, let's go ahead and see. And again, guys, remember, it's not, if you don't know how to do 15, I really strongly urge you to just write it down and then go look at the answers and see if you can figure it out. All right, working backwards. So let's talk about it real quick. All right, and again, I don't mind for now statements and reasons. All right, number 1, angle 5 is congruent to angle 6. And of course, that is given. Now, in my opinion, you should write and you should mark them. All right. Now we're trying to figure out why angle 4 and angle 6 are supplementary. All right. So if I was looking at this, because they've introduced supplementary, I would want to go ahead and say that angle 4 and angle 5 are linear pairs, right? Now, I believe they're linear pairs because that's what's given, right? What? That's what we're talking about right now, okay? Angle 4 and 5 are linear pairs. I kind of think that is, if we look at the definition of linear pair just says they are what? They're supplementary. Does everybody agree with me on that? All right. But we have to actually say angle 4 and 5 are linear pairs. And if you want to, we could have said that's given. All right. That's given from the figure. Does everybody see that? All right. Now, once you say they're linear pairs, you can say angle 4 and angle 5 are supplementary. And that, believe it or not, is the what? Definition of a linear pair. And because they are supplementary, they add up to what? They add up to 180. But I don't really care about the 180 because I'm looking at the word here, supplementary. Does everybody agree with that? So now if angle 4 and angle 5 are supplementary, and we're trying to show that 4 and 6 are supplementary, then what can I replace 5 with? 6, right? So step 4, in my opinion, it'd be real easy to say angle 4 and angle 6 are supplementary. And we could say that's just a what? That's just a substitution. Does that make sense? How's that read? Make sense? All right, how about my homeschooler guys? Is everybody okay with that? Feel free to jump in if you're not sure about something. All right, is everybody pretty comfortable with that? I don't think it's that hard. All right. So, yes, sir. can we do 14? So, yeah, we can do it, but Morty, tell me this. If ABC is a right angle, then angle ABC is 9 degrees, right? Then you could say that angle ABD plus angle DBC is equal to angle ABC, right? And that'd be the angle addition postulate, right? And then we can just make a substitution. Do you agree with that? Yes? All right, that wasn't too bad. All right, but I would like to go ahead and get started with today's lesson. All right. Morty, you sure that was okay? All right. So again, let's flip over now to today's lesson, which is 2-7. So let's take a look at that. All right, put that in Notability real quick. And I failed to say that, you know, when we're waiting, you guys, in the morning, just go ahead and load up the next worksheet. All right. And like I said, you do this or you learn this in 6th grade. All right, and then we're gonna prove a few things before we get going. But here, we say we have 2 lines, and then we have what's referred to as the transversal. All right, and a transversal is just a line that intersects 2 other lines. All right, so let's take a look at this transversal. This is considered the transversal. All right. Now, I want to make a quick note here, and I think you should also. This is on the inside. This is on the what? Outside. That's on the outside. All right. Because we're going to call them interior and exterior, right? So we have alternate interior, alternate exterior, we have corresponding, and we have consecutive interior. All right. And for some reason, that didn't ring a bell for some people. All right. I'm not real sure. All right. But the main things you're going to review is alternate interior angles. So let's look at the alternate interior. 3 and 5 are alternate interior because they're on alternating sides of the transversal in between the other 2 lines, or on the inside. All right, another alternate interior angles would be 4 and what? 4 and 6. Now again, I don't think you have to make many notes on that. To me, that's just common sense, right? You're inside and you're on alternating sides. Just like 1 and 7, we could call 1 and 7 are called what? Alternate exterior angles. That is correct. 1 and 7 are alternate exterior angles. All right, and then let's take a look closely at 2 and 8. That is also a what? That is also an alternate exterior angle. Everybody good with that? I mean, to me, it just makes logical sense here. All right, now the one that doesn't make as much sense, which people get mixed up on, is corresponding angles. All right, so let me show you corresponding. 2 and 6 are corresponding. Why are they corresponding? Because they're on the same side of the transversal and on top of the lines. So I used to say this was the right top. That's corresponding. All right. I also have the right what? Bottom. Does everybody see that? So 3 corresponds to 7 because it's on the right side and on the bottom of the line. Then we have corresponding on the left side. So 1 corresponds to what? 5. That is correct. And then we have 4 corresponds to what? 8. All right, is everybody happy with that explanation? All right. So we have the interior angles, we have alternate interior angles, we have exterior angles, we have alternate exterior, and now corresponding. All right, now the next one, real quick, hopefully remember this. We have consecutive interior. Now, to me, that was easy because I already knew alternate interior. So what does consecutive interior mean? Consecutive interior means they're on the inside, but they're on the same side as of the transversal. So there's alternate interior and consecutive interior. 3 and 6 are consecutive interior, and what? 4 and 5 are consecutive interior. All right, so those are the big words for today. Those are the big words for today. All right, does anybody have any questions with that? Yes, sir. Now that's something I didn't mention, correct? Yeah, so believe it or not, we don't really talk about consecutive exterior. You with me? I don't know why exactly. Right, if you're talking about consecutive interior, you should be able to talk about consecutive exterior. All right, but for whatever reason, I have no idea why they didn't say that. Yes. Well, I don't know, but to me, consecutive interior is just talking about the ones in the interior on the same side. So to me, logically, I would have said, why not call these 2 and 7, call those consecutive exterior, right? I mean, that's all we're saying. I mean, they just don't for whatever reason. And I'm not understanding exactly why. All right. So now let's go down here. So it says use the figure in the example. So let's just talk about it real quick. And sometimes, you know what I like to do, guys? Sometimes I like to copy this and I like to put it somewhere else so I can see it better. All right, that's what I'm going to do. I'm going to put it right there. All right, now they're trying to be confusing, so don't let them be. 9 and 13 are what, guys? Yeah, corresponding. 9 and 13, those are corresponding. All right, let's go to the next one. 5 and 14. So I'm going to highlight 5 and 14. Those are just actually.
Are they alternate interior?
Wow. So let's take a look at that. I just got done saying something and they are. So what I'm going to do now is this, guys. I want to do this so you can see what I mean. Those two have nothing to do with this over here. Does everybody agree? Well, I'm just going to wipe this out so you can see it better. So those to me would just be called what? Exterior angles, right? And that's what I was just saying. We don't really call them what? Consecutive exterior. Does everybody see that? Right, so in our list of angles, we would just say those are exterior angles, okay? But technically we could call them what? Consecutive exterior angles, but all right, it's kind of a silly question. All right, so now what I'm gonna do is I'm gonna go back and put it back so we can see it now. Okay, so let's do 4 and 6. What are 4 and 6, guys? Yeah, is everybody with me on that? So 4 is here, 6 is here. So those are definitely alternate interior. All right, let me erase a little bit now. All right, let's see if we can get the rest of them. 1 and 5. What's 1 and 5? Corresponding. If you don't know, speak up now. All right, if you don't see it yet. Or they try to confuse you with all the different lines. 6 and 14. Oh, yes, very good. Whoever said corresponding. 6 and 14 are corresponding. Yes. Yeah, I'm just looking the same one. Yeah. Yeah, I was like that too. I was like, what figure are they looking at? Right, but then they said in exercise 1 through 12. All right, 2 and 8, somebody help me. Alternate exterior, good. Angle 3 and 11. Corresponding, good. 12 and 3. Wait a minute. But the interior is kind of silly because they do call those what? Consecutive interior. Consecutive interior. All right, 4 and 6 are what? Alternate interior. 4 and 6 are alternate interior. And 6 and 16. Ooh, don't be fooled. 6 and 16. Alternate interior, yes. Alternate interior. All right. 11 and 14. Consecutive interior. All right, Morty, tell me. Four and 6. Alternate. So look, 4 and 6. And honestly, here's what I'm going to put on the test. I like this question, right? Because you have to understand. The problem is, and here's what I want to show you. The problem is this is in your way. So it's hard to see. You see what I'm saying, right? Right, so remember, geometry is visual. So you got to kind of clear things up. And you see how that just messes people up when there's more than, right? Yes, ma'am. All right, let's look at number 5. I'm going to erase this again. So now I'm going to highlight 2 and 8. So let me get rid of this. And I think it's good. 2 and 8. Here's a 2, and here's an 8. Oh, hold on. 6 and 14. I can highlight that for us. 6 and 14. 6 and 14, right? Now, once again, this is in the way, right? So 14, I want to write this. 14 is the top right. You hear that? And 6 is also the top right. So those are corresponding. Make sense, right? All right, so here we go. I don't remember where I'm at now, guys. Someone's going 11. 11 and 14. So those are just what? Everybody agree? Consecutive interior. And then 10 and 16. Yeah, alternate exterior. All right, alternate exterior. And again, guys, speak up, please. If you don't see something, it's good. It's all right. Yes, ma'am. Or yes, sir. I have no idea what you said. 10. 6 and 16. So here's a 6, and here's a 16. So now, again, I'm trying to show you something important. This right here is in the way. So 6 and 16 are on the inside, and they're alternate interior. Okay, good question. I'm really happy with you on that. So watch, I'm going to back up here. Now I'm going to erase this. You see it now? Yeah, an alternate just means they're on opposite sides of the transversal. You agree with me? All right. Yes, sir.
How do you know what which one's theory?
Okay, so that's been a good question. Everybody asks me every year, right? So let's look at this, and so I can try to show you how I know which ones. All right, so he was having trouble with 10 and 16, right? So 10 is this angle, 16 is this angle, which means this has nothing to do with it. You with me on that? That's how I do it, all right? Because they can throw all kinds of stuff at you, all right? All right, hopefully my homeschool peeps are doing good, all right? Now, again, I don't think that's that hard. We've done that before, yes. That's okay, come on, just tell me. Okay, so let me move this out of the way again. You're asking me about 1 and 5, right? So now what I'm trying to show you is if I'm talking about 1 and 5, then nothing over here matters. Just because of the perspective. So watch me now. Watch. 6 and 14. Now I'm talking about 6 and 14, so those don't matter. And again, I totally understand. That's why I'm saying you guys got to speak up if you don't know something, because it's visual, right? And it's difficult. And it would be real simple if we just did this. If I just did this line, and then I did this line, everybody would be happy. But then as soon as we throw another line in there, people get confused. All right, so you got to remember to cross things out or try to visually cross them out. All right, I think that's pretty good. All right, you should have a pretty good understanding of everything now with those words. All right, so now let's see what's for homework. All right, now we're going to try to knock out the homework as quickly as we can. All right. Classify the relationship between, okay, so let's just knock these out real quick. 1 and 8 are what? Alternate exterior. Okay, 2 and 4, corresponding. And then 3 and 6, alternate interior. And then 6 and 7, yeah, we call those consecutive interior. Okay. Now what we're going to do is we're going to do a couple proofs real quick. Okay, guys? Everybody's got to look and listen now. All right. Now, the real important part now is going to be able to take a few things. All right. And so right now I'm going to do a what? A statement and a reason. Now watch what I'm going to do. If I remember from 2.6, didn't we create, or was it 2.5? Oh, here we go. Look right here. Get that out of the way. And now I'm going to come here. I'm going to copy that. I'm going to move that back. And now I save myself some time. There we go. All right. Now, what we're going to do now is we're going to try to prove a few things. All right. Now, I'm going to write this down. Corresponding angle, and why am I going to write postulate? Corresponding angle postulate. Why is it called a postulate? Because, yeah, we can't prove it. All right, so that's kind of silly to me. So let's look at the corresponding angle postulate. Corresponding angle postulate says if two lines are parallel, then the corresponding angles are what? Are congruent. Are congruent. All right, that's a corresponding angle postulate. If two lines are parallel, then the corresponding angles are congruent. That's a postulate. Are you with me? Then, which you guys already knew that. You already knew corresponding angles are congruent if the lines are parallel. Then we're going to have what's called the alternate interior angle theorem. And what does the alternate interior angle theorem say? If two lines are parallel, then what? Alternate interior angles are what? Congruent. Is everybody hearing me? Right? Now, what's bizarre to me, which I pointed out to my geometry teacher, was this. You're telling me this cannot be proven, but to prove alternate interior angle theorem, you're going to use the corresponding angle postulate. Right? That didn't make sense to me. Does everybody agree with that? Does everybody see the kind of like the weird thing about that? All right. We can't prove the corresponding angle postulate, but we're going to use it to prove the alternate interior angle theorem. All right, so that's what we're going to do right now. Yes. Yeah, if two lines are parallel, then the alternate interior angles are congruent. You with me on this? All right. So now what I'm going to do is we're going to prove that real quick. All right. So, and what I'm going to do is just put this up here real quick as I'm going to call this angle 1. I'm going to call this angle 2, and I'm going to call this angle 3. All right, that's how we're going to do it. And you'll be amazed at how simple it is. All right. So, and we'll call this, just for now, line L and line M. All right. So we have to be given that LM is parallel. Did I agree with that? They're definitely parallel. All right, and it's cut by that transversal. Let's call that T. All right, so line L is parallel to M. And what's the reason? Yeah, it's given. So what is true about angle 1 and angle 3? They're congruent, right? Angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3, and somebody tell me why that is. Yes, because it is a corresponding angle, what? Postulate. It is a postulate. It's the only one that is a postulate. You're going to use that postulate to prove all the other theorems. Is everybody good on that? You're going to use that postulate to prove all the other theorems. Any issues? Okay. So now, how can I prove that angle 2 is congruent to angle 3? Someone help me out. Tell me. No, we haven't proven that yet, but that's a good thought. Somebody tell me. Good. Bo. No. Tell me. No. No. All right, my homeschoolers, you can help me out. I need to yell at you guys too. Tell me, how can I prove angle 2 is congruent to angle 3?
Angle 1 is congruent to angle 2.
Why is that?
Because then you can like substitute them.
Why is angle 1 congruent to angle 2?
I forget what it's called.
Oh, come on. After all the great thinking. Tell us, Charlie. Yes, they are vertical angles. We are brilliant. Thank you. Step 3. angle 1 is congruent to angle 2. That is called the vertical angle theorem, the vertical angle theorem, all right, which we could prove, all right? So now that 1 is congruent to, angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3, then we can say clearly what? Angle 2 is congruent to angle 3, and that's by a what? That's by a substitution. All right, so we have now proven alternate interior angles are congruent. All right, we have proven alternate interior angles are congruent. We could also prove that alternate exterior angles are what? Congruent. And that's very, very similar to this. All right? So we have alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. And then we have to prove that consecutive interior angles are what? No! Consecutive interior angles are what? Let's look. Right here. This and this are consecutive interiors. So what would they be? Supplementary. That is absolutely correct. We're going to show that alternate exterior angles are congruent, but consecutive interior angles are supplementary. All right? These are theorems. This is a theorem, and this was a theorem. All right, because we can prove it. So we can prove it. The only one that is a postulate is which one again? Corresponding angle postulates. Corresponding angle postulates. All right, so that's something you have to know. All right. So now what I want to do is I just want to continue on here, all right, with the homework, and I think we're going to do the proofs later down the page. All right, so let's look back up here now. With that information, angle 1 is 94. If angle 1 is 94 degrees, all we need is 1. If we know 1, then we know them what? We know them all. All right, so I don't like to really answer 5, 6, 7. I'm just going to go ahead and answer what? All of the angles. That's what we're going to do. So over here, angle 7 is how many degrees? 94 degrees because they are vertical. What's true about angle 3? 94 degrees because that is an alternate interior angle. What's true about number 5? 94 degrees. So you can see 7 and 5 are corresponding. They have to be congruent. 3 and 5 are vertical. 3 and 7 are alternate interior. 3 and 1 are corresponding. That's what you're supposed to see. All of those are what? 94 degrees, and all of them are congruent. Now, what are all the even numbers going to be? How much? 86 degrees, 86 degrees, 86 degrees, 86 degrees. All right, that's easy, very easy. Now, what I usually tell kids, if you forget, all of the obtuse angles are congruent and all of the acute angles are congruent. Anytime you see an obtuse and you see an acute, then they have to add up to what? 180. That's how simple this is. Super easy. All right, so here we go. Angle 4 is 101. So here we go. 101. So angle 2 is also what? 101. What about 6? 101. And what about 8? 101. What about 5? And 7? 3? And 1. Now again, guys, we literally did that in 6th grade. All right, you did that. All right, so I'm sure it's no trouble for you. All right, now, do I care about the postulate or theorem? No, because you could have done it a lot of different ways. You could have done it a lot of different ways. All right, so let's move on. Let's see what else we got. Okay, so number 12. All right, somebody help me. What is x going to be? 125 degrees. So what's y? 125 degrees. I told you guys, it's easy. Okay, what are these two angles called here? Alternate exterior angles. And alternate exterior angles are what? Equal. So now we can do the mental math real quick and say that x is equal to 114. That is true. X is 114. All right, now if I'm going too fast, let me know. Yes, ma'am. Speak up. Because didn't we just say that they're equal? Do you agree? So we would say that x minus 10 is equal to 104. You with me? It's easy. Very simple. All right, so let's look at 14. Now, sometimes it's kind of hard, but this, I think, is that right there. All right, and I'll make sure it's perfectly clear on your quiz. So now, those are what type of angles? And so if they're alternate interior, they are equal. So everybody can do the mental math real quick and tell me x equals 70. Thank you very much. X equals 70. All right, now if you can't see x equals 70, I can write the equation for you, right? We would just say 2x minus 15. Because they're alternate interior, it would be x plus 55. Everybody happy with that? I'm happy. All right, 15 through 24, you should be able to do. Now look how they're trying to be sneaky down here, right? That's kind of annoying. Be careful when you're doing it. Be careful. And then down here, you've got parallel lines, maybe a little bit harder. Let's look at 35 for a quick second. So somebody tell me what's going on here. What equations do I want to write with number 35? Tell me. Yes. Mr. Stauffer, what? Yes, so you would write what, though? That is correct. You with me? Right? Now, this and this, there's no real name for it. Does everybody agree with that? But what do those two angles have to do? They have to be what? 180. Yeah, because one is obtuse and one is acute. That means they have to add up to 180. So if you wanted to, you could just say y plus 25 is equal to 105. Everybody okay with that? Y plus 25. Oh, hold on. I made a mistake. Thank you. Y plus 25 plus 105 is what I was trying to say. Is equal to 180. And yes, you're right. It would have been 75. All right, double check that now because I blew that. All right, make sure you're with me now. All right, double check. Yep, I made a dumb statement. Okay, now I want to look at something else. Okay, so let's just look at 38 real quick. Now, here, I always used to try to teach kids this little technique that should help. What you want to do is if you ever get stuck, is just extend the lines. Right? You want to extend the lines. And the reason why you want to extend the lines is because that is helpful in seeing the alternate interior. Right? Does everybody see how much easier it is to see now? Because then you can look at this and say, this angle and this angle are called what? alternate interior angles, so they are what? They're equal. Then you would say this angle right here and this angle right here are consecutive interior, so they add up to what? 180, right? Does everybody see that? It's a lot harder when they don't draw it out that way. All right, hopefully you agree with that. All right, so make sure you're doing that. All right, let me work the proof with you guys. I'm trying to think. So copy and complete the proof for theorem 2.15. What theorem 2.15 is that consecutive interior angles are supplementary. Consecutive interior angles are supplementary. Is everybody with me on this? All right, that's what we're proving right now. As soon as you prove something, you have to prove it every time now. Nope, you can just say it's true. All right, so here we go. What is true about statement A? Yeah, I'm just going to write this whole thing. Copy, paste. Let's put that in. All right, I'm going to highlight it so I know I added that. Okay, so now here's what I want. Angle 1 and 3 form a linear pair. What's that? Now there's been some discussion about that, but 1 and 3 form a linear pair. I would almost have to say, yeah, we can do definition of linear pair. I would almost have to say that's given, but I want to go back to our definition of linear pair. So let's put that down, definition of a linear pair. And now I want to go back to something real quick. All right, I'm going to go back to our other notes real quick. No, it wasn't here, was it? Is it almost time to go? Well,
Yeah, we have 6 minutes.
all right, thank you. All right, so hold on, 2.5. I don't remember where it said linear pair postulate. All right, well, I'm going to look that up again. All right, because I don't have my book real handy. So let's just continue on. All right, but I want someone to ask me about this again tomorrow. So make sure somebody does. All right. Definition of linear pair. I would almost say that's given too, but definition of linear pair is okay. Now, if two angles form a linear pair, then they are supplementary. So what do we want to write for C? Yes, that's exactly correct. Thank you. Angle 1 plus angle 3 is equal to 180 degrees. And then angle 2 plus angle 4 is equal to 180 degrees. Now, someone tell me, please, about D. Nope, 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 nope. I don't think so. Yes, they're alternate interior angles. So alternate interior angle theorem. All right. Well, we used to just write AIA, alternate interior angle theorem. All right. Or I don't even mind you. I don't even mind you saying alternate angle or alternate interior angles are congruent. Does everybody see what I'm saying? All right. Because you're not going to remember all the names or whether it's a postulate or whether it's a theorem. So a lot of times you just write down what it is that makes it true. All right. So now finally, we're real quick. Measure of angle 1 is equal to measure of angle 4. Measure of 2 is equal. That's definition of congruence. And then our final statement is to do what? Now, it says up here, angle 1 and angle 3 form a linear pair. So now we can say what?
Well, isn't one of the
Look right here. Can't we just say that now? And we're using a what to do that? Substitution. All right, now it kind of was in a little rush here. It's substitution. Now, again, how do I know it's substitution? I'm going to highlight. Angle 1 and 3 form a linear pair, right? And 2 is congruent to 3. So I'm replacing 3 with 2. Does everybody see that? All right. So now we've just proven that the consecutive interior angles are supplementary. All right. Now, 48 and 49, don't look at the answers. Try to do that on your own. All right, those are two tricky ones. All right, and I'll give you a hint. You may have to add a line. All right, try not to look at the answers. All right, for that. All right, guys. So finish that up for homework. All right, I got 2 minutes. Finish everything. I think it's super easy. All right, I think it's super easy. Something you can be done really quickly. All right, my homeschoolers, you guys have a great day, okay?
Okay, bye.
Bye-bye.
Thank you. Bye.
Thank you.
Thank you.
You're welcome. And